Guys, good morning. This is Miss Morell, and I'm here with your class recap from Monday and Tuesday, September 28th and 29th. Can you believe it? It's almost the 1st of October already. Crazy. Anyway, in class on Monday and Tuesday, we went over the independent work from the previous week, which was to read and explore information about Newton's second law of motion, also called the law of acceleration. And it basically tells us that if you apply a force to a mass or an object, it will accelerate. Now remember, accelerate just means a change in motion, and that can be speed up, slow down, change direction. And the only thing that causes those changes in motion are unbalanced forces. So what you're actually talking about here in simple terms is you take an object and you cause the forces acting on it to become unbalanced. It will change its motion, just like we learned the first week of school. Now we're just defining the rules that go with that. So Newton's second law is called the law of acceleration, and it just says if you apply a force, you'll cause an object to accelerate. The smaller the force, the smaller the acceleration. The bigger the force, the bigger acceleration. So we gave you some graphics here. So little force, little acceleration, big force, big acceleration. The law also allows you to think about how the mass of an object affects its acceleration. Let's go back to our previous example that we used with inertia, which is the inertia of an elephant is greater than the inertia of a man, a human. And so therefore, it takes a lot more force to overcome the inertia of the elephant and cause it to move compared to the human. Well, this is Newton's second law, FMA. FMA says that the more mass an object has, the more force is required. This just gives you a formula for doing it. If you apply the same amount of force to the elephant and the man, you're likely to move the man a lot sooner than you are to move the elephant because the elephant has larger mass. So here is, again, another graphic for you. Same force applied, small mass, really large acceleration. Large mass, very small acceleration. There's a really simple equation to help us calculate all of these changes in motion. And it's force equals mass times acceleration. And lucky for us, this three variable formula fits into a triangle just like speed. So you'll be using FMA triangles just like you use DST triangles. So on the triangle, since you have mass times acceleration, those two are on the bottom, and the F for force is on the top, and then the triangle works the exact same way. So today in class, we're going to be practicing using this equation to solve for different variables. We then gave you another cool NFL science video since we're all excited about football. And then just some more interesting information and examples of Newton's second law of motion. We then asked you to go back to another Study Jams video because the questions at the end where it says test yourself are really good questions that will really give you a sense of whether or not you understand this material, if you need more work, if you need to come see your teacher, all of those things. So we went over all of that in class on Monday and Tuesday. And then we also went over a really cool Everglades project, airboats in the Everglades. So we gave you 2 pages, an explanation page that asks how do thrust and drag forces affect the motion of an airboat. Gives you a little background. This is kind of like the robot races with Ruthie and Irwin, same sort of graphics. This information sheet is just telling you what the values are. So the boat mass is in green here. And on the active page, you're going to be able to use the slider to change the mass. So it'll also let you change thrust force. And then you've got a graph that you'll be able to follow as you are doing the simulation. You're going to adjust its thrust 3 different times and see how that impacts the motion of the boat. I suspect if you think about it, you could actually predict what's going to happen. We know the more mass the boat has, the harder the thrust is going to need to be to get it in motion. So we'll also be looking at a velocity graph for that same information. So after you read through, or we went through the explanation page, we then asked you to complete an assignment. And this was just like the Ruthie and Irwin thing. You clicked there to open the assignment, and then you ran the simulation, and then you answered the questions. As always, it's really helpful to pre-read the questions before you watch the simulation so that you know what it is that you are listening for and looking for, and what kinds of things you're going to be responsible for answering. There were also some additional pre-AP and GT assignments. So if you have questions about those, please see your teachers specifically about that. And then finally, we gave you the pre-work for next class is Newton's third law of motion, another page for you to work through with videos, examples, and finally the link to the study jams with the really awesome questions at the end. So please do those, check your learning. Also, the link to today's homework is live. So we've completed our 2 days of warm-up. So your homework and explanation were also posted, and we completed that. So that's where we are as of Wednesday and Thursday, September 30th and October 1st. Wowee. So I hope this gets you where you need to be. Have an awesome weekend.